We'll start off with this bottom one here. It's divided in half. Click apply, then go at the top. And then we'll go to the side member here. It's divided in half. Also the member to the right is divided in half. We have to add the member here in the middle. We'll go to add members. If we look at the group name, it should be W02. So we're going to change that, the group label. Go to W02 and then click on 7116 to 7117, apply. Then we'll go back to the member divide by ratio. We'll click on that member, divide it in half. Go back to add members, and we'll add the members across here. Once we have that, we're going to add the dummy members, so we'll change the group label to the DUM, and we'll add those, so it'll be 7112 to 605F, 7116 to 605F, 7120 to 605F, and 7118 to 605F. And we'll do the same thing for the other ones. Once we're finished with that part, we're going to go ahead and save it. We need to still define we need to define, if we put this in 3D, the dummy members are not defined. We're going to define that by going to Property, Member Group. We see in the undefined list here, we got the dummy. We'll click on that, add. This is a tubular member, so we're going to change the group type to tubular. And we're given the outside diameter is 12.75 and the wall thickness is 0.375. We'll go ahead and apply that. Now we see that there's no undefined groups, and we see on the model here that they have been defined. We can look at the whole structure. If we go to Display, Active Isometric, Apply, turn off the group labels, we can see at each elevation everything's been defined. So we'll go ahead and save it. Go to File, Save As, and we're going to change the ending from 05 to 06. Then we can go ahead and close this out. We see our model 06. We can open this with the data gen. And we can see that our legs now, when we did the joint can design, we originally had a length of 1, and now you see that's changed over here. The lengths have automatically been calculated and changed, and they're all increased greater than 1. So we're going to go ahead and open this SACSDeck2Part3 with Precede. The next thing we're going to do is define the deck beam offsets. So for this, we're going to go to Display, Plan. We'll start the first deck elevation. It's 15.3. Apply that. Now we have our deck plan elevation. We're going to go to Display, Group Selections, and we're going to exclude the wishbone and conductors from this view. So pull over the conductors, pull over the wishbone, uncheck the Show Unattached Joints, apply, and that's good. Then we're going to go to Member, Offsets, and we're going to highlight the entire plan view. So we're just going to make a box around. We're going to left click and box the whole thing. Then in this dialog box here, the member offsets dialog box, it says the offset type, we want to make that top of steel. That way the top of steel is at the joint level for all members. Even if they're different sizes, they'll all be flush. So once we hit that, we can go ahead and apply. And if we turn on the 3D and we go ahead and hit this arrow thing, we can move it. And you can see they're all flush at the top. Now remember, we have to have all these deck beams already defined before we do offsets, because if we were to do offsets and the deck beams weren't applied, we wouldn't know how to move it, the top of steel. We wouldn't know the dimensions. So if everything's already, the members are already there, we can hit top of steel and it's going to put the members top of steel. It's going to calculate that for you. Okay, we're going to do the same thing for the next elevation. So we're going to go to display, plan, go to 23 and apply. So then we're going to go to members, offsets. We're going to highlight all members here. We're going to pick offset type, top of steel, and apply. Again, we'll just resave this real quick. It's the same name, so we're going to go to File, Save As, say OK, and save it as 06. So we'll just resave it and say yes, we want to replace it. All right, the next thing we're going to define member code check properties. So we'll go back to display active isometric, reset, select, apply it. So the first elevation we want to do, we'll go to the Z is 79.5, so we'll go to display plan, negative 79.5, apply that. For this one, we're going to use the KY factors, so we can go to property, K factor, and we'll pick KY. Now we can turn on the, let's turn the solid off, and if we hit this button over here, it gives you the arrows, so it shows you that the X is in this direction. X is always along the member, so that's something you can remember. The Y is already out and the Z would go up and down. So this is a way you can see we're going to be rotating about the Y. That's why we're using KY, because it's restrained here by a leg, it's restrained here by a leg, and we're going this entire distance. So the rotation is about this Y direction here. It's going around that axis. So once we hit the KY, we get this box pull up. We can turn our joints on. If we click on the first member, keep the K factor box highlighted. The first thing we're going to do is hit the joints. So our first joint would be the end here. Our next joint would be the other end of where it's restrained. And then we're going to click on the members. So we're going to click on this member. We're going to hold down the control key. Click on all the members going across since it spans from there to there. Our KY factor would be 1. And we want it to be KY only, which we pick. Once we do that, we can right click or hit apply, and it will then apply it. If we looked at that member now, we can go to member detail. You can see it does the calculation. It put the calculation for the KY for each part of the member. We're going to do the same thing. Keep that K box open. We'll do the bottom here from this end to this end. Highlight the members. Hold down the control key, hit apply, apply it. Do the same thing for the top, 2 end joints. Click all the members, right click apply, Again, click on these joints and hold the control key down, click all members and apply. We're then finished with that elevation. We're going to go to the next elevation, so display plan, we'll go to the -50 and apply. And we're going to do the same thing. It's going to be rotated about the Y. So we'll go to property, K factor, KY. Our first joint and our second joint, the end joints. And then we'll hold down, click all the members. Right click apply. We'll do the bottom here, 2 end joints. Hold down control key, pick both members, apply. Then we'll go to the top, click both end joints, and hold down the control key for all the members and apply. Again, on the right, we'll click both end joints, click both members, and apply. So we're then finished with that elevation. Then we're going to go to the next elevation. So we'll go to plan. This will be the -21, apply. For this, we're going to use the effective length, the LY. You can use either way. You can use the KY or the LY. LY will just give you the length, where the KY gives you the factor. So for this will just show you the other way you could do it. You see the effect, go to property, effective length, choose LY. We'll choose the first joint, the second joint, 2 end joints. We'll still hold down control to click all the members. And then you can see it gives you the effective length 15. We apply. If you check the joint distance, click on the end joint to the end joint, that distance is 15. That's where that effective length is coming from. So if we went to member details and we clicked on a member, we know that the effective length is 15, so it's being restrained from that joint to that joint. So we'll do the same thing. We'll go back to the effective length box. We'll click on the bottom joint to the end joint, click both members, apply. Go to the top, click both end joints, click both members, apply. And on the right, we'll click both end joints, click the members, and apply. And then we'll go to our next plan elevation is 2.0. So we'll go to display plan, 2.0, apply. Again, we're going to use the effective length, so we'll go to property, effective length, LY. We'll go to the left side, pick both end joints, click all the members, and apply. We'll go to the bottom, click both end joints, both members, hold down control, apply. Go to the top, click both end joints, click both members, and apply. And we don't need to really do the right side, but we'll click the both joints, click the member, and apply. And this member is the entire length. So then we can go ahead and close this. And again, we're going to save the model so we have all these changes in here. So we'll go to File, Save As, keep it the same name. So it will be SACSDeck2Part3. We're going to save, and we do want to replace it because we already called it 06. So we'll say yes. And this concludes the deck modeling part. The next part we'll get into is the loading, which will be the next video. Thank you.